All right, in this video, I just wanted to work through some examples of graphing. So I've got 6 examples. These are on the worksheet, the 5.5 and 5.6 worksheet. So if you have a way of printing those, you could follow along there. Nothing really goes on these lines over here. I just forgot to remove the blank. So don't worry about that. We're just really trying to graph. All right, so when you start trying to graph something like this, you remember how we're comparing it to, let's see, I'm gonna have to snip on these. Okay. So when we're trying to graph something like that, we're really looking at y equals a cosine bx minus c plus d. And the a, the b, the c, and the d are parameters that affect what happens to the graph of the basic function y equals cosine x, okay? So what you want to do on this is you want to think about how this is really the 1/2 x is really what cosine is getting applied to. And so you really want to start by figuring out what the 5 key points are. So you're going to start here, okay? And not there, but you're going to start with the 1/2 x. And you're going to set up the inequality. Now, when you're doing sine, cosine, secant, or cosecant, you're going to go between 0 and 2 pi. All right, so then what you're going to wind up doing is you're going to wind up multiplying through by 2. That's still 0. That would be x. That would be 4 pi. That tells you then what to use for your starting and for your ending point. Okay, for those 5 key points. So I'm going to actually extend this a little bit. So that would be 3 pi. I need to get all the way out to 4 pi, okay? And then what I'm really graphing right here, I'll write out, that is where I'm actually going to be thinking about what cosine of 1/2 x would look like. Okay, so what I'm going to do is cut this in half. That would be 2 pi. You can see it from here that it would be 2 pi, or you could do half of 4 pi. In between here, I would have pi. In between here, I would have 3 pi. So those are the 5 key points that it would take to complete one full cycle of your cosine graph, around this unit circle. So remember how we just looked at this, that cosine is the x-coordinates. So you can be looking at the x-coordinates as you go around the unit circle. And so you're going to start where you normally start. The first key point, cosine is 1. You don't go to pi, even though this says pi, because there's that middle thing where you're doing 1/2 of your input, and 1/2 of pi is really pi over 2. So what we're going to get here are really what we're going to get if we go around the unit circle. So we're going to do the usual values we get as we go around the unit circle, which is a 1, a 0, a -1, a 0, and a 1. Okay. Now I like to go ahead and graph that. I'm going to make the pen a little bit skinnier though, if I can. Yeah. I'm going to go ahead and graph those. So at 0, we're at 1. Okay. At pi, we're at 0. And then we're down at -1 at 2 pi, back to 0, and then back up to 1. And you remember how the cosine kind of looks. So cosine of the 1/2 x affected, in this case, just the period. Okay. It didn't affect a phase shift. It just affected the period. You didn't have a c value in there at all. Okay, and of course I could extend it even this way. Okay, to get the rest of it. Trying to make sure I'm going as far as I need to. Down to 1, then back up to 0 when I'm out here. Okay, so I don't want to make it too small. Okay, so that's the y equals cosine x. That's the green one, is y equals cosine 1/2 x. All right, now what the 3 would do would stretch each of those values so that you're 3 times as far away. So where you were at 1, or where you were at -1, you're going to now be at -3. Okay. But these are going to stay fixed. Okay. But you're just stretching the graph. So you're going to go like so. And that would be the y equals 3 cosine 1/2 x. Okay. All right, now the negative out in front, when you consider that, that just takes the graph you just did and flips it. So your low point would be your high point and so on. So it just flips it. Okay, so it's going to do something like that. So the blue one is the one with the negative in there. Okay, and then the last thing I got to do is take care of the 2 right there. So let's see, let's just do a black for that. So the final answer will be in black. So every spot, this 2 is a vertical shift. Okay, so the 2 is going to wind up shifting every single point up 2. So when it used to be at 3, it's now going to be at 5. Used to be at 3, it's going to be at 5. Okay, these used to be at 0, they're now at 2. Used to be at 0, they're now at 2. Make sure you're focused on the blue one when you get ready to sketch it. This one down at -3 is now at -1. Oops, I just said focus on the blue one and then I was on the red one. -3 should be at -1. Okay, here would be another -3, should be at -1. And then get those connected. So I'm thinking about the blue one moving up 2. Okay, so it's going to do something like that. And I can extend it as much as they ask me to. So this is the y equals -3 1/2 x plus 2. Now you could, if you like the idea of continuing your table and actually figuring out what the ultimate value is for the 5 key points, you could really go through and do it that way. You could go ahead and kind of go through a progression of things, like this is what cosine 1/2 x is, and then you could go in and say, okay, well, here's what it would be if I had -3 cosine 1/2 x, and then you could go on and say, yeah, but this is what's going to happen if I have -3 cosine 1/2 x plus 2, and then just look at plotting those ordered pairs. Okay, so that's an option if you want. Okay. All right. Let's go ahead back to the worksheet and let's do the second problem. Okay, let me blow it up just a little bit. So let's think about this. So here, I'm going to want to take the 2x minus pi. This is a sine graph. So I'm going to put it between 0 and 2 pi. I'm going to solve it for x. And so I get my starting and my ending points for my 5 key points. Okay. So it's pi over 2 for my starting, 3 pi over 2 for my ending. And then it might help to look at that to kind of see where you're going to be. Gosh, so that happens in a kind of a small area. I may change the scale on this so it's spread out a little bit more, or just extend it, I guess, a little bit more. So let's do that. Let's just extend out a little bit more here. Okay, so this is pi over 2, that's pi. This would be 3 pi over 2. This would be 2 pi. Okay, so that's pi, that's 2 pi. That'll help. We'll do that. Okay, now when you're looking, do you see the pi over 2 and the 3 pi over 2? You can tell on the coordinate graph that the halfway point would be pi. And then you need halfway in between that. So notice that pi got cut into 4 pieces. So this first tick mark, learn to count these fractions. I tried to do that on like almost day 1 when we were looking at angles. This would be pi over 4. This would be 2 pi over 4. 3 pi over 4, and see I need that. That's 3 pi over 4. 4 pi over 4, this spot right here would be 5 pi over 4. So if I can do that, it gives me an easy way to find those in-between values without having to do a lot of calculation. Okay, but you can take those two and add them up and divide by 2. You can average them to find that midpoint. Okay, so this would be 2 pi over 2 plus pi over 2. Had to get a common denominator, all divided by 2. That's 2 pi plus pi is 3 pi over 2, all divided by 2. And so that winds up being 3 pi over 2 times a half. That gives you 3 pi over 4. If you can avoid that by looking at the graph, feel free to do that. So you could do a similar thing to get this one. Okay, so what that does for you is that tells you then that this is the pi over 2 is the beginning point, and the 3 pi over 2 is the ending point, and that one complete cycle of the sine graph happens there. And so then you can think about, well, when I go around usually, and I think about what the sine is, it's the y-coordinate of these, then I know what the values would be here. And this would be what you would get if you did sine of the 2x minus pi. You would get a 0, a 1, you'd be back to 0, you'd be at -1, and then you'd be back at 0. Okay? All right, so you can go ahead and think about getting that graphed, but you might want to, just so you don't have such a messy graph, you might want to go ahead and say to yourself, yeah, and if I wind up throwing the 3 in here, going ahead and putting the 3 in front of that sine x, okay, then this becomes 3 times 0, which is still 0, 3 times 1, which is 3, 3 times 0, which is still 0, 3 times -1, which is -3, and 3 times 0, which is still 0. And so maybe the first thing I'll graph is really just going to be this piece. Okay? So pi over 2 will be at 0. Okay? 3 pi over 4 is going to be up at 3. Pi is going to be back at 0. 5 pi over 4 is going to be at -3. And then 3 pi over 2 is going to be back at 0. So it has that typical look of the sine graph right here, going up to 3 and down. See, the amplitude was a 3 here. So sometimes I'll go ahead and put that in instead of doing the most basic graph. Okay? And then I can extend that in both directions. I just have to be careful. So it has to turn around right here. Has to have the same feeling for the rest of this. And sometimes they'll want you to go pretty far, but sometimes you're just picking an absolute value. I mean, you're picking a multiple choice. Okay? So the blue is not my final answer. The blue is taking into account the y equals 3 times the sine of the 2x minus pi, all of that, okay? All right, then, do you remember what the -1 does? That's the d, right? This is the amplitude. The b and the c affect the period and the phase shift. So this had a phase shift. It started at pi over 2. It moved to the right. The sine graph moved to the right. It didn't start at 0. It started at pi over 2. So it had a phase shift of pi over 2. And then the new period the whole entire sine graph happened between pi over 2 and 3 pi over 2. And the difference in those two is pi. So the entire graph happened in just a single pi. Okay? All right. So that's what we've taken care of so far. But do you remember what the D part does? Okay. Okay. That's after you finish that, you're going to subtract 1 from all of these points here. Okay. And you can actually show that, if you wanted to. So you can go ahead and put that in the chart if you like that. And so you can have a little column where you take the 3 sine 2x minus pi, all those values you have here, and just take away 1. So this will be at -1, this will be at 2, this will be at -1, this will be at -4, this will be at -1. Basically, what you're doing is shifting every spot down 1 unit. So just get all those key points kind of shifted down 1 unit so that you can get your graph drawn. Okay. All right, so it's going to do something like that'll be down from here, it'll be down 1. Hit it there. Okay, so the whole entire graph just shifted down 1 unit. So what you see in red is the y equals 3 sine of 2x minus pi minus 1. Okay. All right, so pi over 2, that was your phase shift. So it went to the right pi over 2 units. The difference between these two, the 3 pi over 2 minus the pi over 2, was 2 pi over 2, or pi. That's the new period. Okay, so the whole entire sine graph happens now in just pi distance. Okay, the 3 is your amplitude. So instead of reaching a high point of just 1, it goes up to 3. But then this is a vertical shift. And since it's negative, you're going to go down 1. Okay. All right. Let's look at a cosecant graph. Okay, so on this one, we're trying to do 4 cosecant x over 3. All right, so I'm going to take that part right there and set up my inequality. Cosecant is kind of like sine. So I'm going to do the 0 to 2 pi. So I'm really going to have 0 is less than x is less than 6 pi. So it's going to take all the way until you get to 6 pi to get the full cycle. Okay. Now, I know I'm trying to do cosecant, but I think it'll help if you think of it as a sine to start with. Okay, so first, the 5 key points. 0 is the beginning, 6 pi is the end, so 3 pi is halfway in between, and then halfway in between those would be 3 pi divided by 2, and halfway between those would be 9 pi divided by 2. Okay, so that's a little unusual. All right, now if we do that, and then we look at trying to graph the sine of x over 3, these values we get for the output would be the typical sine values as you go around the unit circle. So you just have to kind of remind yourself of those. And so it normally has a sign to start with at 0, then it goes to 1, then it's back to 0, then it goes to -1, and then it's back to 0, just like before, but we have a different starting point and a different period. Okay. All right, so now that right there would be the sine of x over 3. All right, if I put the 4 into the picture, the 4 is really dealing with the amplitude. So what I sometimes like to do with that let me move that line over just a little bit, is just slip the 4 right here. Then this is going to be 4 times 0, 4 times 1, 4 times 0, 4 times 1, negative 1, and then 4 times 0. So if I want to go ahead and graph y equals 4 sine of x over 3 over here, 0 is going to be 0. Okay. 6 pi is going to be 0. And 3 pi is going to be 0. And then you know how the sine graph works. Halfway in between those two, that's this location. That's the 3 pi over 2. Okay. Halfway in between there is going to be up at 4. And halfway between these two, which is right there, is going to be down at negative 4. So this, oops, didn't mean to start it looking so far to the left. Let me try that again. So this is going to go up to 1, down to negative 1, and back to 1 as you move from 0 to 6 pi. The blue that I just did, of course, it would continue, okay? It would continue if I extended it, okay? This would continue too, all right? The blue one is y equals 4 sine of x over 3, okay? So when I'm ready to do cosecant, we do that in red. So now let's do this. Let's do the cosecant. What I'm going to do is everywhere I have an x-intercept, I'm going to have an asymptote, okay? And then at these high points, it's going to flip this way and make those little U shapes we're used to seeing. It's going to be over a little more than that. Do something like that. And then this one, would have a piece in here too, okay? And then the red is the graph of y equals 4 cosecant x over 3. So I normally go on and graph the sine graph first when I'm dealing with cosecant, and then I just locate the cosecant once I see the sine graph, because then it's easy to see that these x-intercepts on sine, cosecant is the reciprocal of sine. So if you came over here, you could do it this way too. If you came over here and looked at 4 cosecant x over 3, what's going to happen is you're going to wind up having this be undefined. Okay, undefined, okay? All right, and then this is a little tricky because you normally, if you're going to do the cosecant, you normally wait to do the 4 part. So if you're going to do the cosecant, you would compare to these values, compared to these values, the red ones, and you would do 1 over 0, 1 over 1, 1 over 0, 1 over negative 1, 1 over 0, and you would get the values, okay? And then you would say, all right, now I'm going to do the 4 part, and you would come in and do the 4, okay? Well, that would stay undefined. This would become 4. That would stay undefined. This would become negative 4, and that would stay undefined. Okay, again, this kind of thing is so much easier in person. I'm really worried about how many of you are not able to join me in my virtual sessions. I just think it's so much easier to make sure you're understanding. It really worries me. All right, let's go ahead and look at this one. Here's a secant. Okay, so when I do this one, I'm going to be thinking about cosine really first. Okay, so let's think about this. So first, I've got a snippet. Okay, now look, when you wind up doing the test and graphing, I don't want your answer to be this perfect graph ultimately, or you just pick the multiple choice answer. I want to see your thinking and your thought process. So you need to do a similar analysis. So you need to set up your inequality. And I'm thinking about graphing y equals cosine x plus pi over 4. So that's why I'm gonna do that first. So I'm going to subtract pi over 4 from all three sides. I don't know why I put a 2 pi over 4. It was 2 pi. Okay. Subtract pi over 4 from all three sides, all three parts. Okay, and then this just needs to get simplified over here. Okay, notice though, that's actually your new period. So this one, the period is still going to be 2 pi. It's just your starting point. This is your starting point, is now to the left, pi over 4. Okay. All right, and then I am going to simplify this to find my ending point, but that right there really is the new period. It's the same as the old one. There wasn't a number out in front of the x, is why that's the case. Okay. All right, so then I want to just simplify that. So I need a common denominator of 4. So I'm going to multiply the top and the bottom by 4. So that's 8 pi minus pi. That's 7 pi over 4. Okay. So cosine of x plus pi over 4, I'm going to begin at negative pi over 4. I'm going to end at 7 pi over 4. Okay, then halfway in between, and then I'm going to do halfway in between each of those pieces. Okay, and I showed you how to do this on the unit circle. I think that sometimes is good if you want to try to figure out those halfway spots. Negative pi over 4 is here, and 7 pi over 4 is, let me draw that better. And 7 pi over 4 is here, okay? So if you looked for halfway, let me erase those. If you looked for halfway, wouldn't it be back here? Would be halfway between those two. Okay, and see how that kind of cuts this in two pieces? So let's cut everything else into two pieces. Okay, so this is your 7 pi over 4. Okay, so this would be 1 pi over 4. This would be 2 pi over 4. This would be 3 pi over 4. Okay, so that's going to be the halfway. And then to get halfway between these two, wouldn't it be right there, which is right at pi over 4? And then halfway between these two should be right here. So if this is 3 pi over 4, that's 4 pi over 4. This would be 5 pi over 4. Okay, those would be my 5 key points. And I know what cosine does when you do the normal move around the unit circle. We've done it a bunch. It would start at 1. And I'm not moving to these angles right here. So don't make that mistake. Let me even erase those. I'm just thinking about what typically happens in one full cycle of cosine. You start at 1, okay? You go to 0. Okay, then you're over there at negative 1, then you're back at 0, and then you're back at 1. Okay? All right, now, do you see how out in front of this I have the 5 on that secant? Okay. In front of the secant, I actually have negative 5, but let's start with the 5. So if I threw a 5 in here, this becomes 5, 0, negative 5, still 0, 5. Okay. All right, so what about the negative that's in front of that? So if I throw the negative, let me put that in green. So if I throw the negative in front of that, see how that's going to then flip it over? This will be negative 5, 0, 5, 0, negative 5. So I could go all the way to that point where I'm graphing really y equals negative 5 cosine x plus pi over 4. So I could go and do that. Okay, so if I did, I've got to be able to identify the locations of these. So you have to think a little bit about where you're at. Let me go ahead and extend here to 2 pi. Okay, and so if that's pi, this would be pi over 2. So I need to be halfway to get to to fourths between each of these. Okay. And this right here would be 3 pi over 2. Okay, so if you're counting in fourths, this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and we'd be over here would be negative pi over 4. Okay, this would be negative pi over 2. All right, so we're going to start at negative pi over 4, and we're going to be at negative 5. Okay, then at pi over 4, which is here, we're going to be at 0. Okay, then at 3 pi over 4, this is 2, this would be 3 pi over 4, I'm up at positive 5. 4 pi over 4, then 5 pi over 4, I'm back to 0. And then 6 pi over 4, 7 pi over 4, I'm going to be down at negative 5. So I know the look of the basic cosine, it just got flipped over. So it's going to do something like this. And then that would continue. This would continue. Let's see. Let me think where the next thing would happen. So that's at pi over 4, negative pi over 4, negative 2. So it would really be there. Finally come back down. Okay. And kind of keep going. All right. Now, when I want to do the secant of that, let me do that in red. The secant of that, everywhere you have an intercept, okay? And that, let me make sure I have that one right. So if I continued in that direction, this is at pi over 4, and this is at 5 pi over 4. Pi over 4, 5 pi over 4. Okay, so that is actually a pi distance. So if this is at pi over 4, then that would have to be 1, 2, 3. Yep, that would be the right spot. So I was looking to see if I had where I'm going to get my asymptotes. Okay, so it's going to flip, and then this will be flipped. Okay, this would be flipped, and this would be flipped. Okay, so once I get the y equals negative 5 cosine x plus pi over 2, what I can do at that point is just create the u's off of each of those high and low points, okay? All right, now the last two I'm going to go ahead and do on this same video. Let me go back and snip it again. Okay. So let's go and see if I can snip both of these in one. Okay, so let's look at these two. Do a full screen snip. All right, I find that the cotangent and the tangent ones are a little bit easier if you have the gist of what the graph typically looks like. Okay, so on these, I still need to figure out my new starting point and ending point. So for tangent, you know, then it usually starts at negative pi over 2 and goes to pi over 2, and it does that in between there, is what I think. Okay, so I'm going to set up my inequality. Okay. And this one I'm going to multiply through by 4. And so that same thing is going to happen, not from negative pi over 2 to pi over 2, but from negative 2 pi to positive 2 pi. So the same concept, the same thing is going to happen, but from negative 2 pi to positive 2 pi. Okay, so let me get over here a little bit further. Okay, so negative 2 pi would be over here. Okay. All right, so the starting point is negative 2 pi, and the ending point is 2 pi. Okay. All right, so I know what I have at the start and the end of a tangent, and right now I'm just looking at the tangent of x over 4. The start and the end are undefined because they're 1 over something. All right, and then halfway in between those two would be at 0, and the halfway in between point on this, okay, is where it would be at 0, okay? Then when you look at halfway between that, you'd be at negative pi, so you'd have to be there at -1, and when you're over here at pi, you're going to be up at +1, okay? Those are what the typical values were. You had those key points coming from here. You had an asymptote on one end, an asymptote on the other. You had 0 in the middle, and then you had it hitting 1 and -1, okay? So what's going to happen, you could go ahead and think through what's going to happen if you wanted to over here in your chart. So what happens if I put the 3 in there? So if I put the 3 in there, well, that's still undefined, but now that's -3, 0, 3, and undefined. And then, well, it wasn't 3, it was -3. So what if I put the negative on that? Well, then this becomes +3, that's still 0, and that becomes -3. And then what we'll graph is these two, okay? So we'll come in and we'll have our asymptote at -2 pi, and then we'll have another asymptote at 2 pi, okay? All right, halfway in between there, you know your tangent graph is going to be at 0. And then typically, you know, your tangent did that, right? But it's got the negative on it, so that got actually flipped over. So we can actually look right here to verify what we're thinking. So when you're over here at negative pi, you're actually going to be up, not just at 1, but all the way to 3, because that stretched vertically a little bit. And when you're here, halfway between 0 and 2 pi, that's pi, you're going to be down here at -3. So instead of going in its usual direction, it's going to look like this. And that's going to happen from -2 pi to 2 pi. This approaches over here, okay? Hate it when it gets messy. Okay, and then see, that would happen again. So if I went from 2 pi and did another, see how the new period actually, the new period is 4 pi, where before the period for your tangent was just pi. Okay, that's because of this divided by 4 piece in here. So the new period is 4 pi. That means it got stretched out horizontally. And then the 3 stretched the graph vertically. So instead of just being at 1 and -1, it went to 3 and -3. And the negative is what caused it to flip over the x-axis rather than being in its normal orientation. Okay? All right, and then if I wanted to extend this, I'd have to go all the way out to 8 pi over here to get my other asymptote. It'd be at 0 here, and then halfway between those, it'd be at 3. Halfway between these two, it'd be at -3, and it would do another one of those. Okay? All right, so that's the graph of number 5. All right, and then let's go ahead and look at this one. This is similar, but it has a phase shift. Okay, so we're going to first take our x plus pi over 2. And for cotangent begins at 0. The asymptotes actually are at 0 and at pi. And so that's the inequality you want to solve. You want to think about the starting and the ending point of the main cotangent graph. When you subtract pi over 2 from these, if you take pi and subtract half of pi, you're going to have half of pi. Okay, so your old period was pi, okay, and your new one is pi as well. See how there's no number in front of the x? So the period isn't changed. It's still that a whole section of cotangent happens. It just is going to be shifted, and instead of being from 0 to pi, instead of being like it normally is, which is like that, between 0 and pi, it's going to get shifted over, and I'll do a better graph, but it's going to shift over, and it's going to do that right there, okay? All right, so let's see how to think about this one. All right, so it doesn't hurt to go ahead and do this. Your 5 key points, starting and ending. Halfway in between is 0. Halfway in between 0 and pi over 2, if I cut that in half, that'd be pi over 4. If I cut that in half, that'd be negative pi over 4. Okay? So I know it's undefined at the beginning and the ending points. Okay? And when I get in the middle, that right there, it's going to be at 0. Okay? And then cotangent normally goes this way. Okay? So you're at 1 there and you're at negative 1 there. Okay? So cotangent typically does that. Okay? So it would be, if I right here had cotangent of x plus pi over 2, I'd have undefined, I'd have positive 1, 0, negative 1, undefined. Okay? So you can graph that and then stretch it, or you could throw the 3 out in front. That would still be undefined. That would be 3, still 0. That would be negative 3, still undefined. And then just get that plotted. So your asymptotes are going to be at the negative pi over 2 and the positive pi over 2. And they're going to happen every pi units. So you could think about that, every pi units, you're going to have another asymptote. All right, and then in between there, you're going to have the typical cotangent graph. So you're going to have at the halfway point, it's going to cross there. This was not reflected. It was a positive 3. So instead of being at 1, you're going to be at 3. And here, instead of being at negative 1, you're going to be at negative 3. So it's just a little steeper, a little more stretched out. And then you can do that again, as many times as necessary to get your repeated graphs. All right, so there you have it. Graphing variations of sine, cosine, and tangent, and also looking a little bit at cotangent, cosecant, and secant. Okay, so have fun with this. I don't want this to be a burden. It's just kind of a fun process.